In physics problems, we often end up dealing with vector quantities, quantities with magnitude and direction. And one example of a problem is that we know the x and y components, the horizontal and vertical components of a vector, and we want to know, say, the magnitude and the direction of the vector. And I often get the query, is the direction always the inverse tangent of the ratio of the y component of the vector to the x component of the vector? Well, the answer to that question is it depends. It depends on the angle that we're trying to calculate. Are we calculating the angle of the vector with respect to the horizontal? Are we calculating the angle of the vector with respect to the vertical? Are we calculating the angle of the vector with respect to the positive x direction? Those can be different angles. Angle with respect to horizontal, angle with respect to vertical, angle with respect to positive x direction. And so the calculation depends on the particular angle that you're trying to calculate. So let me show you an example. In this particular problem, we've got a vector called A, and I've pictured that vector A by this little arrow here. And that vector A is a vector living in two dimensions, horizontal and vertical dimensions, x and y dimensions, and we're told that its x component is -3, so it goes in the negative x direction. Its y component is +4, so it goes in the positive y direction. And you see that in this picture here. The x component of this vector is -3. The y component is +4. And we're asked to figure the angle of this vector, the direction of this vector. And there's several ways we could quote the angle of the vector, the direction of the vector. Let me just show you. I could calculate the angle of the vector with respect to the positive x-axis. I could calculate the angle of the vector with respect to the horizontal. Or I could calculate the angle of the vector with respect to the vertical. So this angle in red, this angle in magenta, this angle in green are just different ways of quoting the angle. And if I was to answer this question of what is the direction of the vector, I could quote either of those angles, any one of those angles, but I'd have to be clear about which angle, which direction I'm quoting. And so I'm actually, in this case, going to calculate all three angles using the tan function, the inverse tan function. And as we calculate all three angles involving the inverse tan function, we'll get some experience in using it. So let's start with the angle with respect to the positive x-axis. So I'm going to call this method number 1. Here's our axes. Here's our vector. And we're going to calculate this angle here. So to calculate this angle, we'll just call it theta. We take the inverse tangent or arctangent of the y component of the vector divided by the x component of the vector. And in this case, the y component of the vector is +4. The x component is -3. And so the argument in the inverse tangent is minus 1.33. And if you take the inverse tangent on your calculator, you'll get, I believe you'll get, I got on my calculator, minus 53 degrees. Now, there's an important point here. There is two angles. There are two angles that have a tangent that's minus 1.33. There's minus 53 degrees, so that would be 3 degrees below the horizontal here. And there's a second one that has an angle that's 180 degrees bigger. So although the calculator just gave us minus 53 degrees, there's a second angle, 180 degrees bigger. It's 127 degrees. And those two directions are shown here. This one up towards the top left, that's 127 degrees around from the positive x-axis in the counterclockwise direction. This one downstairs here, that's 53 degrees away from the positive x direction in the clockwise, the negative measuring an angle direction. And so the inverse tangent of minus 1.33, the ratio of the x and y and x components, gives us these two angles. And you have to pick the one that matches your particular vector. In our case, we can immediately see, right? It looks like this is 127 degrees in the positive direction around to the vector that we have. It's not this answer, negative 53 degrees in the clockwise direction around to this vector. So this is the correct answer. This is not the correct answer for our particular case. And so one way I could answer the direction of this vector is it's 127 degrees in the counterclockwise direction away from the positive x-axis. Another way of quoting the direction of the vector here would be to quote this angle here. This is the angle above the horizontal axis. And so let's look at calculating that angle here. Now, when I think about calculating this angle, what I'm going to think about specifically is the right angle triangle that the vector itself makes, that's the hypotenuse, with this vertical and this horizontal. So we're going to think about that right angle triangle and this angle, we'll call it theta again, within that right angle triangle. That right angle triangle, if that's theta in this corner on the bottom right, the adjacent side is AX and the opposite side is AY. And the length of the adjacent side is the magnitude of AX, and the length of the opposite side is the magnitude of AY. So in this case, to calculate that angle theta, I'm going to take the inverse tangent of the opposite side of the triangle, its side, to the adjacent side of the triangle, its size. In the language of the components of the vector, that's the magnitude of opposite side is AY divided by the magnitude of the adjacent side, that's AX. That's arctangent of 4/3. And if you calculate the arctangent of 4/3, there's no minus sign here. If you calculate the arctangent of 4/3, that gives you positive 53 degrees. There's positive 53 degrees from this horizontal to the direction of this vector here. So that's another way of answering the question, with this angle in this corner. The third way of answering the question, if we're not already exhausted, is by calculating the angle with respect to the vertical. So here are the axes again. Here's the vector again. And now I'm going to calculate this angle here in this corner, the angle with the vector with respect to the vertical. And when I calculate that angle, I'm going to think about this right angle triangle. It's made up of the vector itself with the hypotenuse, and then a horizontal side and a vertical side. And the horizontal side, the length of that side is the magnitude of AX, and it's the opposite side of the triangle because it's opposite the angle we're quoting. And the adjacent side is the magnitude of AY, and it's adjacent because it's next to the angle we're quoting. So finally, when I calculate this angle, I'm going to use the fact that the angle is equal to the inverse tangent of the opposite side of that triangle divided by the length of the adjacent side of that triangle. And in this case, in terms of the components of the vector, the opposite side of the triangle is AX, its magnitude. The adjacent side is AY, specifically its magnitude. And if I plug in the magnitudes, I'm going to get AX's magnitude is 3, AY's 4. So we got the arctangent, inverse tangent of 3/4. That comes out to be 37 degrees. And 37 degrees is this angle here, the direction of the vector with respect to the vertical. So look, I worked through that calculation in quite a lot of detail. I wanted to make the point that when you calculate the direction of a vector from the X and Y components of the vector, you want to be careful in thinking about what direction am I calculating? Am I calculating a direction with respect to the vertical, with respect to the horizontal, with respect to, say, the positive x-axis? Because that's going to affect your calculation. In some problems, they may ask for the direction with respect to the vertical, the direction with respect to the horizontal, the direction with respect to the positive x-axis. In other problems, you may be able to calculate any of those angles as long as you're clear about which angle you've calculated. So we calculated, firstly, the angle with respect to the positive x-axis. There we used the inverse tangent of the ratio of the y component of the vector to the x component of the vector. And we incorporated the signs of the y and the x components of the vector. Secondly, when we calculated the angle with respect to the horizontal, we just thought of a right angled triangle that's made up of the components of the vector and the vector itself. And then we calculated the inverse tangent of the size of the opposite to the size of the adjacent side of the triangle. And then we thought about the angle with respect to the vertical. We also thought about a triangle, a different triangle, and we calculated the angle for that different triangle based on the inverse tangent of the ratio, the size of the opposite to the adjacent of the triangle. So that's an example of calculating the direction of vectors. It's an example of using tan theta to calculate inverse tan theta to calculate the direction of vectors. And some of the important points, some of the tricky points, some of the places you can make mistakes in calculating the directions.